Hello friends, welcome all of you once again. Today we see the new point in rotational dynamic topic. So let's start today's lecture. The new point in rotational dynamic topic is analogous quantities between translational motion and rotational motion. Analogous quantity means similar quantities which have seen in today's lecture, translational motion and rotational motion. So let's see the first quantity. First quantity in translational motion, it is linear displacement, and symbolically representation of this is S vector. In rotational motion, it is represented by the quantity angular displacement, and symbolically representation is the theta vector. So S vector, it is in the translational motion, theta vector, it is in the rotational motion. So the interrelationship between these quantities, we have get the relation, that is S vector is equal to theta vector cross R vector. So this is one is the first quantity. Second quantity is in translational motion. Second quantity which we study here, it is the linear velocity. Symbolically representation is, we know that v vector is equal to ds vector divided by the dt. In rotational motion, it is called as the angular velocity. Symbolically representation, it is the omega vector is equals to d theta vector divided by the dt. V vector in translational motion, omega vector in rotational motion. So let's see relation between them. We know that is v vector is equals to omega vector cross r vector, which is the relation between linear velocity and angular velocity, that is v vector is equals to omega vector cross r vector. Let's see third quantity. In translational motion, the third quantity, it is the linear acceleration. Symbolical representation of this is, we know that a vector is equals to dv vector divided by the dt. That means rate of change of velocity with respect to the time. In rotational motion, it is called as the angular acceleration. Symbolical representation, it is the alpha vector is equals to d omega vector divided by the dt. A vector, it is the linear acceleration in translational motion. Alpha vector, that means angular acceleration in rotational motion. So let's see relation between them. That is alpha vector is equals to a vector cross r vector. Let's see next quantity. In translational motion, the next quantity is inertia or simply mass. Symbolically representation, it is the small m. And in rotational motion, moment of inertia, as we have already studied, that is symbolically representation, it is the capital I. So relation between them is I is equals to integration of r square dm is equals to summation of mi into the ri square. Next quantity is the linear momentum. Symbolically representation is, we know that p vector is equals to m into the v vector, that means mass into the velocity. In rotational motion, it is represented by the quantity angular momentum. Symbol, it is L vector is equals to I into the omega vector. Relation between them is L vector is equals to R vector cross P vector. Then we see the next quantity. In translational motion, force, symbolically representation is, we know that F vector is equals to dp vector divided by the dt. Rate of change of linear momentum with respect to the time. In rotational motion, it is called as the torque, and symbolically representation, it is tau vector is equals to dl vector divided by the dt. So relation between them is tau factor is equals to R factor cross F factor. Let's see next quantity. In translational motion, the next quantity is work. We know that W, that means work, is equals to force into displacement. That is W is equals to F factor dot S factor. In rotational motion, work can be symbolically represented as W is equals to tau factor dot theta factor. Let's see the next quantity. Next quantity name it is the power. Symbolically or in terms of the formula, P is equal to dW by dt. So here we simplify this relation. As we know that P is equal to formula dW by dt. As we know that work is equals to the force into the displacement. So taking derivative, we have to get F factor dot into the bracket ds factor divided by the dt. As we know that rate of change of displacement, that means it is called as the velocity. So power in the translational motion can be represented as P is equals to F factor dot V factor. So in case of rotational motion, the power can be similar to the formula, that is P is equal to dW by dt. Here we also simplify this relation. We have to get P is equals to dW by dt. That means here we have to calculate the formula, that means d dt of tau into the theta. Taking derivative, we have to get tau factor dot d theta factor by dt, as d theta by dt, which is called as the angular velocity. That means power's formula P is equals to tau factor dot omega factor. So here friends, we see some analogous quantities or similar quantities in case of rotational and the translational motion. So we today here stop. In the next video we see some other interesting points.